top of you.
Podcast number 1 for the balancing or chemical equations packet.
Now we're going to put all these together and see what happens when we mix different molecules that we've been learning about for so long. And we're going to try and give you a really good visual so you can try and imagine what the molecules are doing on a molecular level. So we want you to be able to draw pictures to show different balanced equations.
Wait, why do we balance equations anyway?
The reason we balance equations is because of this topic called, or this idea called conservation of mass. And what does that mean?
I think I've heard of that before. That's a law, right? A scientific law.
It is a law.
All right. I think it means that, from what I remember, that when you start a reaction, you have to have the same amount of mass at the beginning of the reaction as at the end of the reaction.
So you don't lose any mass.
Yeah,
The
so
atoms
it's
just get rearranged. You might want to write that down. Conservation of mass. Atoms, you must have the same amount before and after a reaction. Mass cannot be lost. It's just like, I guess, when you eat some food. If you have a cookie and you eat it, it changes in your body. But all the cookie is still accounted for in your body. It just gets broken down and changes into other things, right?
Yes,
Conservation
of course.
of mass. So there's two different parts of a chemical reaction, reactants and products. What are reactants?
Those are the things that go into the reaction. They're the starting materials of the reaction.
You could say those are the things reacting.
You could, and that would be probably a good thing to say.
And products are?
It's not just a clever name.
Products are produced?
Exactly.
Wow, the definition is the term. But there are two new definitions that you need to be aware of. You get reactants and you have products. And reactants come together, they rearrange into products. So let's take a look at an example here.
So we're going to take a look at a reaction with two reactants. It looks like Na and Cl.
And on my reactant side, they are together.
Okay, so they're bonded.
They're bonded together. There are two separate things bonded together, an Na and a Cl.
We've got a picture here of a compound that consists of the sodium atom and the chlorine atom. Actually, the sodium ion and the chlorine ion, because it's an ionic compound. So in a chemical equation, we would represent that with the formula NaCl.
Right. All right. NaCl, right? Except I see two of them. So can I write like Na2Cl2?
That would be incorrect.
Two Nas and two Cls.
There are two, but there's two of the compounds.
Oh, they're separate compounds.
Right.
So we need to put a 2 out in front of the NaCl.
Yes.
There are two separate NaCls. That 2 is called a coefficient.
Just like in math, right?
Just like in math.
Like 2x. 2 is the coefficient
The
of x.
NaCl, that's the formula for one of them. You're only looking at the ones connected. There's one Na and one Cl. So you can't say that there's two of each of them. But we say there are two whole units, two whole molecules, two NaCls. And those are going to rearrange themselves, and they're going to form different products. So let's see what happens when they react. Oh, they've rearranged themselves. And notice I still have two Nas and two Cls, but now they're arranged differently.
So now you can see in the products, the two Nas are separate from each other. They are now individual atoms, and the two chlorines have bonded
connected
with each other.
They're connected.
I think I remember something about chlorine.
If you're drawing these pictures, which you should be, you may want to shade. We can visualize them in different colors, but in your notes you may want to shade them differently. But let's take a look at these two products here. Notice there are two separate Nas, so I write a coefficient of 2, and the chlorines are bonded together, so there is one of those molecules, one Cl.
And from what we learned before, that makes sense, because remember, chlorine is a diatomic element, and whenever it goes off by itself, it bonds to itself.
In pairs of two chlorines. How about that?
Makes so much sense.
So the diatomic molecules, those 7 diatomic molecules, they're going to come up a lot in this chapter. A lot. Let's take a look at another one. Here's another reaction involving 3 different types of atoms now: sulfur, hydrogen, and silver.
Okay, so it looks like the sulfur and the hydrogen are bonded together in a compound in the reactants, and the 2 silver atoms are by themselves.
They are. So with the sulfur and hydrogen, there are 2 hydrogens and 1 sulfur. So we're going to write that down.
Well-
Dang it. So if we look at the reactants, the first thing I notice is that there are 2 silver atoms, and they're separate from one another.
So we write that down as the coefficient 2 and Ag.
Not Ag2, they're not connected, 2 separate silvers.
So that coefficient tells us we've got 2 separate silver atoms in a reaction.
And the other one, I see 2 hydrogens and 1 sulfur. So 2 separate silver atoms are going to be added to 1 H2S. This is where you get the subscript.
All right, and they're all bonded together, so we write it down as one compound together.
1 unit. And they're going to combine. Now I've got, looking at the top, 2 silvers and 1 sulfur connected at the top. There's 1 molecule there,
Silver sulfide, Ag2S.
if you're
And
trying to
then
name it.
the second one here, the 2 hydrogens are bonded together. Remember, they are bonded together. We have 2 hydrogens together, so it's H2.
They form a unit. All right, let's work backwards. Let's try this one now.
So that'll be good.
All right, so let's take a look here. Now I've got 3 separate types of atoms. I made an inventory over here, similar to what we did, but now I'm going to be drawing them in.
So that seems like it's a good first step, is to draw a picture, a
key.
circle, which is a key for us for each individual atom.
Let's put an X for the sulfur.
Looks like the X-Men symbol.
Maybe the hydrogen. We'll color him in. And the oxygen will be open, like an oxygen, like
Yeah,
O.
makes sense.
All right, so O2, what's that going to look like? There's 1 O2 molecule,
It means we have 2 O atoms in here, so 2 oxygen atoms. But
and they're connected.
exactly,
2
the subscript
O's.
means they're connected.
H2S, that looks familiar. We've got 2 hydrogens and 1 sulfur.
So we're going to have the 2 hydrogens and the sulfur connected with each other.
And the sulfur I'm going to put in the middle, because generally atoms arrange themselves around something in the middle.
Right, and remember what we just did, we kind of talked about the individual atom, the one that's by itself, or the one that there's one of, usually ends up the central atom of molecules like this.
H2S. Awesome. Those are my reactants. Products. I have H2, 2 hydrogens connected. There's my 2 hydrogens. Let's color them in, because the hydrogens are dark.
So we've got those 2 together, bonded together because of that subscript 2, and then we also have SO2, which again is making a unit for us with the sulfur in the middle and the 2 oxygen atoms on either side of the sulfur, all bonded together.